Okay, so for the temperature part, I've made up a short description of a hypothetical case, because if I use the information you have for your study, I would be giving you the answers. So this is hypothetical. It's not the same species you have in your final project, so just know that. But the short description says, body found on August 2nd, 2024, around 7 a.m. in Midland, Texas. You collected maggots from the mouth and ears, preserved 50 and rear 65. The preserved maggots were identified as Lucilia sericata, and the reared specimens confirmed this identification. You were not able to leave the temperature probe at the scene, and the investigators want to know what is the time of colonization. So, as you've seen in previous modules and you will see in next week's module, when looking for the temperature, you usually need to find temperature that's at least 2 weeks before the body was found and a week after the body was found. So in this example, the body was found on August 2nd. So you would need temperature data from July 19, 2024 to August 12, 2024. So let's do that together. To find the temperature data, we need to go to NOAA, so NOAA.gov. And then I already know the steps, but this would be faster if you follow along. So we go to Tools. We go to Weather and Climate. We scroll down to Historic or Certified Weather Data, and then click on Past Weather Data. And then you go to the search tool up here and you land on this page. So we're gonna do daily summaries. And then we need the date to be from July 19, 2024 to August 12. So make sure you're on the right year. And again, this is for the hypothetical case. For your case study, it's a completely different date. So make sure you have the right dates. So July 19, and then 2024, August 12. Apply. And then we want to do cities and write down our city. So it would be Midland, Texas. And I have a typo here. Midland, Texas. Okay, so let me make this a little bit bigger. You get the map, and then you can zoom in and find your scene location, so Midland right here. And then this usually gives you the weather stations in order, but you can scroll down or put the name here, and then it should give you the closest one, but double check that before selecting one. For this, we're gonna use the first one. You want to add to cart, and then click here. You want to select the CSV version so you can use it on the Excel. Double check your dates, July 19 to August 12, 2024. And then this is the weather station, continue. And we really need the air temperature, but I like to mark all of them just in case, and then we can delete it when we're using the Excel spreadsheet. But mark all of them, continue. And then you have to write down your email here and submit order. And it should take like 5 minutes to get to your email. Okay, so when you get your email, you have to click here on download. And that will get you a CSV file. Okay, so we have our raw data, but we don't need all of this. So what I like to do is I copy the first row with the titles, copy, and then paste it on a new spreadsheet. And then we can go down using these two that we mark right here, the temperature max and the minimum, to where we have the dates that we actually need. So it would be from July 19 all the way to August 12. Copy and paste. Okay, so now we can delete all of those extra columns that we don't need. So we don't need the weather station names. We don't need all of this. And we don't need all of this. Okay, so there's two things that I like to do. The first one is to sort the dates from the most recent to the oldest. So we do that by clicking on the column and then going to data, sort and filter, and sort from newest to oldest. And you want to do the expand section, which means it would sort not only the date column, but these two as well. So sort. Now we have August 12th as the first one, and then all the way down to the 19th. The other thing we want to do is convert these temperatures from Fahrenheit to Celsius. So let's make sure we label this correctly. These are Fahrenheit, and we want the temperatures in Celsius. For that, we need this formula. So our temperature in Fahrenheit minus 32, parentheses, divided by 1.8. So to apply that to these numbers right here, we have to do equals, parentheses, click on your Fahrenheit temperature, minus 32, parentheses, divided by 1.8. And you can click and drag to the side and then click and drag down. And we can always use 2 decimal points. Okay, so that's that. Oh, and the other thing we also can do to have less numbers to confuse us, we can mark the date that the body was found right here. And then if we were able to put the probe on the scene, we would use these temperatures right here, but we couldn't do that, so we don't need them for the specific project. So we can delete that and work from the day before the body was found down. Okay, so now we sorted our dates. We have our temperature in Celsius, or degrees Celsius, and we deleted all of the extra dates. So now we can find all the information we need for a species to calculate the ADD and then do our time of colonization estimates. So if you remember from the scenario, our species is Lucilia sericata. So we can find the temperature or the minimum threshold for Lucilia in the literature, and we also need to find developmental data that sort of matches the temperatures that we saw at the scene. But before we do that, we want to calculate the average temperature for the historical data. So T average. And for that, we can do equals average and then select these two. Make sure you're selecting the maximum and minimum for the same day. And then click and drag. Okay, so in order to find development data, that matches our scene data, we have to calculate the average of the time period for the scene. So we already did the average for each of the days. So now we want the average for the whole range. And here we have it, 28.61. Okay, so when we're looking for development data, we can find anything that's close to these 28.61, and I already have that. So give me 1 second. Okay, so from the literature, I found that the minimum threshold for Lucilia sericata is 10 degrees Celsius. And then I found development data for 30 degrees Celsius in hours. So we have here how long each of these stages last in hours at 30 degrees. But since we're going to do accumulated degree days, we want to change this information to days and then do the degree days and the accumulated degree days. So first we need to change these hours to days. We do that by dividing the numbers by 24. And then we can click and drag and 2 decimal points. Okay, so now we can do the degree days. And if you remember, our formula was average temperature minus the threshold times a unit of time. Okay, so equals our average temperature would be the 30 degrees at which this species was reared. So parentheses 30 minus our minimum threshold, which is 10, parentheses, times our unit of time, which is the days. And then we can click and drag 2 decimal points. And now we can do the ADD. So for the first day, ADD is just the accumulation of the degree days for each of the stages. On the first day, we only have the degree days for the egg stage, so it would be the same. But then when we do the accumulated degree days for the second stage forward, we do however it took to that for that stage plus however it took for the previous one. And then we click and drag. And one hint here that you did it right is if you have the total here, it's the same for the total here. So we did that right.